friends, this is David Cuartillas, co-founder of Arduino, and this is the first streaming session from the second season of the Arduino LiveCast series. It has taken us a bit of time to get started. It's been mostly because I've been really busy with my academic life, but now we're here back to show you some nice projects that are being prepared by our team. So the goal for the live streaming sessions for the second season is going to be to do projects that are suggested by you. But obviously it's not going to be easy to get you to suggest projects if you don't know you have to suggest projects. So we're going to start the first couple of weeks by showing off a couple of very simple projects that are suggested by Josephine and Carl. Josephine and Carl couldn't be here today, but they are two of the guys working at the Arduino office in Malmö, Sweden. So as you know, I'm transmitting live from my shed. This is my real shed, but I can show you around, but I will show you around as the program goes on in different programs. And so this is my desk where I sit and invent my own stuff. And we're gonna see today a project that's related to, let me just turn this on, plants. So this is strawberry, and this nice strawberry here, it's getting dry because I forgot to dry it. That's the whole idea. And so this program today is called Hack Your Plants. And with me is my daughter Bobby. She's just hiding down there. Come say hello. There she is. Hey. So she wants to see what is that I do late at night, because right now here is 8:20 in the evening in Malmö, Sweden, and it's outside is like a big storm. So you might hear some extra noises, courtesy of the big storm in southern Sweden. So in our new setup, you see we have changed a little bit how things are working, and this is our test live stream. We've changed a bit the look and feel of the program because we want it to look a bit more up to date and a bit less slideshow-like. And as I said, I'm going to be taking projects that people are suggesting. And this week, we have the project title, Hack Your Plants, that is suggested by Josephine and Carl, who are second-year students at Malmö University and are interns at Arduino Education in Malmö. So let's take a look at, oh, this is my desktop, is really messy. Let's take a look at what this project is all about. So in the first place, we're going to be working with Arduino UNO, which is one of your favorite boards. It's the board that's most used in the world of Arduino right now, both as originals and as derivatives. And we're going to be using this very simple and practical moist sensor. So it's going to be used to measure the moisture of the soil of a plant. And so we have this Arduino UNO board, and we're going to use a breadboard, and we're going to use the moist sensor that we already spoke about. And on top of that, we're going to need to look at it a little bit closer to just understand how it works. So you see it's made of two parts, and in this one, the PCB, the circuit that controls the sensor, you see there is a potentiometer that is used to set up a trigger, and that trigger is going to be sending a signal, or it's going to be responsible for measuring the moist, and it's going to send the signal back to the computer. On the other hand, this is the connector that's going to go back to the computer. You see the connector has 3 pins, and I'm going to just take this in my hand, and you see I'm having the bag of components in my hand, and the 3 pins are the pins are labeled BCC, GND, D0, and A0. So this makes me think, without really knowing, this is a task that these guys gave me. Makes me think that this sensor can be used in 2 different ways. One is to measure an analog value, and the other one is to measure a digital value. So if you measure a digital value, going back to this, probably this potentiometer is going to be the one triggering the value that determines when the signal is low or high. And so this is the sensor that's going to be detecting the moist, and you could as well just use 2 wires or 2 nails nailed into the soil. And what we're going to be measuring is the difference in the voltage between these 2 metallic terminals that we see here. So this is 2 metallic terminals that are connected to these pins. These pins go here. One is connected to ground, as is labeled here in the circuit. The other one is going to the amplifier, and this is setting up the trigger. And I guess it's possible to also measure the analog value on the other pin, and we will just make a couple of experiments with it. So for mounting the thing, since this circuit is having male pins, we need a couple of wires that are having male pin connectors on the one end and female connectors on the other end. So it's possible to connect these pins on the one side and these ones back to the breadboard or to Arduino. And obviously one is going to be used for power, the other next is going to be used for ground, and the final one is going to be used for signal. And in this CSS circuit, I'm going to just check because Carl and Josephine prepared this thing for me just to make sure I have something that works. They are measuring the analog signal, which means most likely that they might or might not be using the potentiometer, because the potentiometer, if it's used for triggering, is used, as I said, could eventually also be used as a gain for the amplifier, but I'm actually not really sure how it works. I'm going to explore this. So the task for me is to really get to know exactly how this works, and we will just see it with software just to see exactly how the sensor works. And finally, I need a bunch of jumper wires and a bunch of resistors that I'm going to use to trigger some LEDs. So the idea is that with these lights, I'm going to be giving an indication on the level of moist in the water of the plant. And you can imagine that from there you can move on into making whatever else you might be interested in. So let's make it happen. So the circuit's going to be looking like this. And as I said, Josephine and Carl already prepared the circuit for me, and I'm gonna be cheating, so I'm gonna be using the circuit they prepared just to make it real fast, because as I said, my intention today really is to check that everything works on the live streaming. And so I'm gonna just show you the top view out here. So it's a top view, and you see I have the components. Imagine that at super speed I go like and I mount everything. And there you go. It's mounted exactly as in the presentation I was just showing you, like here. Well, this is not exactly the same sensor you see here in the presentation as the one we are having, because this is the one that Fritzin is offering. This is the one that Fritzin is offering is one that is made by SparkFun, and it has direct connectors straight into the board. The one we're using has an external circuit that's controlling the gain of the signal or the trigger. As I said, I'm not really sure how it works, so I'm gonna explore what I have. So this is the components we're having. This is a sensor that is already connected, and this is the LEDs. This is the Arduino board, and here's my plant. So I will just stick the sensor inside the soil like this. The plant is being intentionally left dry a little bit, so I'm really sorry for it. And today we're gonna change that. It shouldn't be like this, but we had to have a plant that had a dry soil, so we could actually test the soil. It's not that moist. And then we just need to connect our USB cable to the board, and I'm not really sure where I have a USB cable because I've been just traveling lately and I haven't been taking care of my workspace so much, but here I have a USB cable. So I just plug this to my hub. And to the board. Great. So then, as I said, right now I have the A0 signal connected to the sensor, to the A signal in the sensor. So I wonder what are the values that I'm getting there. So I'm gonna just check on my Arduino software just quickly how the sensor works. As I said, Carl and Josephine prepared this thing for me, but they didn't exactly tell me how the sensor works. This is my challenge for the day, just to figure out how the sensor actually works. So I'm gonna just write a small program to read on the serial port how the sensor works. So here is the Arduino IDE. So I will first say I'm gonna use a serial port. And here you go. And basically, the only thing I want to do is to have a variable that I will use to do an analog reading of A0, which is the pin where I connected the sensor. If you remember, I'm using the analog signal, and I will just print out, print line the value that I'm reading, and then I will make a small delay so that I don't saturate the port too much, and I will make a reading every half a second, so 2 readings per second. I'm gonna save this program with a funny name, and I'm gonna call it hack plant save. Okay, I will just make sure that everything is configured properly on my board. Again, so now I'm back into Arduino. I'm just gonna put this window back here, and so if I want to basically upload this program to the board, which is what I was gonna do before, I'm just gonna make sure I'm showing you this view, and I'm gonna just bring in the Arduino IDE in this window so that you can see it. Here you go. And now on this window, I will just say, okay, I will go to tools and make sure there is the Arduino UNO board and that I have the right port connected. I'll just double check that the board is connected to a port, and here it is, COM3, perfect. And I will just then upload this. I will just upload this code to the board and upload it. So once it's uploaded, then I have the opportunity to check whether the code, which is reading the analog signal from the sensor in the plant, is working properly. So it's the first time I'm compiling since a long time ago, so it's going to take a bit of time because it's compiling all of the libraries and everything. Once it's done, we will be ready to check things out. Okay, it's been uploaded, and if I open the serial port monitor, clicking up here, it opens this other window, and here you see it. So right now, this is measuring, thanks to this sensor, the humidity of the soil. As you see, the moment I took it out from the, you didn't see this because I have to show you this on this other view. Okay, you see, here's the sensor, and I have it out of the soil. And if I take a look at here, you see that the sensor is giving me a really high reading. If I go back into digging the sensor in the soil, we'll put the plant up here. You see now the sensor is digging the soil. I will just take a look at which is the value, and you see how the value decreased. And I'm gonna just pour some more water. This cup here has a bit of water, so I will just put a little bit of water on the plant. So I pour some water in the plant, and let's take a look at how the moist sensor is behaving. And you see, well, the soil is so dry, but now you see how the value really went down. Okay, so it's very clear that with the moist, the sensor value goes down when we read it as an analog signal. So this is a really good indication, because then I can start working with my plant, and we can work with the sensor to get more, like, pretty accurate values. I can tell you the plant was extremely dry, and when I had the sensor in the air, I had like 1,000, which is like the driest you can get because there is no humidity in the air. Well, there's some humidity in the air, but not enough to stimulate the sensor. When it was in the soil, I had about 600 to 700. When I put water in it, it goes down to 250, and very quickly it rises up to 300 and 320, and you see how the sensor is slowly rising up. So as the water is being filtered through the soil, the moist level changes, which is pretty obvious. So you can in a very accurate way detect when you've been pouring enough water in your plant. So this could be a later project for you to experiment with. So let's take a quick look at the program that Karen and Josephine prepared for me, because they prepared a program that's using the 3 lamps that you see on the circuit. There's just 3 lamps. these 3 LEDs, to indicate the level of moist. And I have no idea how the program looks like. I haven't even opened it. So it's going to be very interesting for me to look at it. I'm going to just open the editor here and copy and paste the code. I'm just doing it on a different window. Actually, I'm going to just open the program straight inside the Arduino IDE. And when I change back to desktop, you will be able to see exactly the code. So here we are, and I change window, and here we go. So this is a program, and it's based on a program that I did in the past. And so the idea is that it's reading the signal on pin analog 0, and it has 3 LEDs, red LED, a yellow LED, and a green LED. And it's gonna have a variable that's gonna be used to read the input from the sensor. And as you see there, then it declares the pins for the LEDs as outputs, turns on the serial port, reads the value on the, it's called here potentiometer pin, but it's actually the sensor pin for the lamp, for the plant, sorry, prints out the value, and if the value is over 900, then it tells you the plant is dry. If the value is between 899, it will not tell you the plant is not moist completely, but it's definitely not dry. And if the value is less than 500, it's going to tell you the plant is not dry. So as you see, it's a very simple program. This is 3 lights to indicate the level of moist in a visible way. At the same time, it's sending the information back to the computer via the serial port. So I will just make sure I can upload this down to the board, and here I see everything is ready. So I just upload this. And so we're going to get visual feedback on how the plant is behaving on top of the information we get on the serial port. So right now it's compiling, and it will upload in a second. And once the program is uploaded, we can check. I will just move the back and forth the moist sensor so we can see the different values. Oh, Hardware uploading, I think this is a minor issue. I will just and it was a problem with the operating system, as you see. So it was nothing of the things that I said. It was the operating system was blocking the serial port because I had the serial port open and I tried to upload without closing it, and so it gave me some trouble. So I'm running too many things in this computer right now, so you most likely will not have this problem, but I'm running presentations and everything. So anyway, so now my plant is going to be showing some data, and this example is sending data a lot faster, as you can see here on the stream. And right now the light is green. I'm going to show you the top camera view, and you see the green light is on. I will bring out the sensor from the soil, and you see when I bring out the sensor from the soil, the light that goes on is the red light, and it's not just properly here. It's just not properly plugged, and this has to do, of course, with the fact that the sensor information now is 2023, which is really high. And as you see right now, the light is actually not on because the program that Carl and Josephine prepared has a small mistake. And this mistake is that when it's 2023, the red light is not going on. If I punch it right now, it's the value is a bit smaller, so it's 900. Okay, but look at the code. Look at the code here. In the code, you see how the value says here smaller than 2023, and that's why the light is not red if the sensor is punched out of the soil. But if I do this one smaller or equal to 2023 and I re-upload the code, we will see how now the light will be red as well when the sensor is out of the soil. So this actually can be used to detect whether the sensor is out or in of the soil. So if the sensor is out of the soil, it's going to give you 2023, or when it's extremely dry. Okay. compiling, and it's giving us some issues right now. And I have to say, there's also a small thing in this program, and it is that it's having no delay every time it's trying to send something, which makes that it's the serial port is always blocked with trying to send data back to the computer. So that's not an optimal position or situation. So I'm gonna just close this window by the way. So that's why I can't upload. So it's better to have a small delay in your program so that the information is not being sent all the time. Because right now, I see I'm having problems to send. I'm just gonna reset the board real fast. So if you have a program that is sending data back through the serial port at full speed and there is no delay, this thing that happened to me right now might happen to you as well. Basically, the program, it restarts after the bootloader starts, and it starts trying to send data real fast. And your IDE might not have enough time to just send the code, the new compiled code down to the board before it's done. So it's a good idea for you to always have a small delay so that you don't saturate the serial port in the computer. So when you send a new program, it has enough time to, upload the new program and so on. So anyway, now it's done. The program is working. The serial port is working. The data is being read. Here's the data. Okay. And here is I'm gonna show you the plant. Here's the view of the plant. Okay. You see now the red light is on even when I unplug it because I corrected this error in the code that was not working when the sensor was out because we had the smaller than 1023 when it should be smaller or equal to 1023. And when I punch it in the soil, in the most humid part of the soil, the most moist part of the soil, you see how it's going down to green. And if I look for an in-between part of the soil, we'll probably manage to get it yellow. There you have it. And if we check the value on the front camera, you see the value is 500 and something. That what corresponds with the code that says if the value is between 500 and 899, is going to be showing yellow light. But the code again is presenting another mistake, and it's that. So you see, Josephine can't really prepare me a trap. So the limits are leaving a hole. If you look at the code here, so if the value is bigger than 900, it's gonna go red. But if it's smaller than 899, it's gonna go yellow. So what happens when the value is 900 or 899? The light will not be on, right? So this should be bigger or equal 900, and this should be smaller or equal 899. And the same happens for the other limit set up down here for when you change from orange light or yellow light to green light. So you have to make this comparison this way, otherwise you're not going to be measuring anything in those in-between points in the case. So, I mean, this program is working regardless because I was never being stopped at those in-between points. So I forgot I have to unplug and replug the board in my computer, and no, I think I made a mistake in. Did I erase anything by accident? Yeah, I made a mistake in the code, sorry, here. And that's it. So this basically is having three sections, it ranges, where you can measure, where you can divide the measurement of the analog signal to turn on and off different lights. Okay, so we just saw how this works, and this is a very simple example on how to measure the moist in the water. I had a couple of small issues, but it has to do most with my setting. You should never have issues like the ones I had. And this is what we were doing. We just had the sensor inserted in the strawberry plant soil to measure the moisture of the soil. And so there is many projects that have been done like this one before. For example, This is Instructables project here at Arduino Sewing Master Sensor that you can check out. And if you want to see that is a lot more fun, you should check out the Botanicals project, which is a project that was made already some years ago, and it's actually part of the permanent connection of the MoMA Museum of Modern Art in New York, which is actually tweeting messages whenever the plant is not being taken care of properly, and it's tweeting in your Twitter account, shaming you for not taking care of your plant. So there's a lot of really fun things you can do, and we recommend that you explore these possibilities with Arduino and whatever other technologies you consider relevant. So friends, this has been our first episode, our test episode of the season 2 of the Arduino LiveCast. I want to thank you all for being here today, and remember that this LiveCast is sponsored by the eCraft to Learn European Research Project, where we're trying to bring sensor and embedded technology closer to teachers that want to learn how to use technology in their classrooms. So thank you very much, and see you next Tuesday here at the Arduino LiveCast channel. Remember to subscribe. Goodbye.